Okay guys, so his first slide's on how an infrared spectrometer works. Now, you'll not actually be directly tested on this, but I really do think in order to understand the graphs and what they're all about, you really do need to understand how it works. But just be aware this won't, you won't find this on the syllabus, but it is important. So I would say there's 4 main points as listed there. I've also drawn a little diagram to help you see what components are inside the spectrometer. So 5 minutes guys, have a crack at this, off we pop. Look, cover right, check, repeat, repeat, repeat. Okay, halfway through guys, just 2 and a bit minutes to go. Just 1 more minute guys, try and get it down 1 more time, really try and make it stick. Okay, sorry about that, guys. I went on for like a minute too long. A little bit distracted then. So this next one is alcohols. This is the graph of alcohols. You'll notice there's two main peaks on an alcohol. One caused by the C2O bond, at 1000 to 1300, and one caused by the O2H bond. Now, this is really important. The way you know whether that OH bond is an alcohol OH or a carboxylic acid OH is by looking for a COO bond, which is about 1640 to 1750. If there is a COO bond, then the OH cannot be an alcohol OH because alcohols do not have COO bonds. It must be a carboxylic acid OH. Now, we do not have a peak at 1640 to 1750, so this cannot be a carboxylic acid, it must be an alcohol OH. That's how you tell. You can't tell what your OH peak is from how broad it is, because how broad's broad and how broad's very broad, and you can't tell from the wave number, because they overlap, they're too close. You might also notice between about 500 and 1000, we've got some extra little peaks there. That's called the fingerprint region. Basically, any peaks less than 1000 you can ignore. They're not going to be useful for you to look at. So, 4 more minutes left, guys. Off we go. Two more minutes left, guys. Notice with the scale on the bottom as well how it works in reverse. Also, between 2000 and 4000 wave number, it crunches down slightly. It gets a little bit squished together. The axes are transmittance and wave number. Thirty more seconds, guys. Okie dokie. So the third slide, this is on carboxylic acid. You'll notice now there is a peak at about 1640 to 1750, so it does have a C-double-O bond. That's how I know that OH is a carboxylic acid OH. Again, below 1000 to about 500, there's a couple of extra peaks. That'll just be the fingerprint region, so we can ignore them. The ones we care about is the OH, the C-double-O, and the C-single-O. 5 minutes, off we go. Just over 2 more minutes left. Thirty more seconds now, almost there, just one more time. Okie dokie guys, and this is either a ketone or an aldehyde. Now you'll notice in this one, we can see some sharp peaks around 3000. We know these will not be an OH peak because OH peaks are either broad or very broad, and these are clearly not that, they're sharp. What these will be caused by is a C to H bond. Now, these peaks would also be there on the last two graphs we looked at. So alcohols or carboxylic acids, it's just that they'd be hidden by the OH peak, which of course is a lot bigger and broader. As we have got no OH peak, we can now see them. We can basically ignore them though, because they don't help us tell what functional group it has. Practically everything has a C to H bond, so that doesn't help us figure out what we've got. In ketones and aldehydes, though, we've also got a C-double-O bond, about 1640 to 1750, so that's the peak we look for. Now, we won't be able to tell whether it's a ketone or an aldehyde just from the IR graph. If we wanted to distinguish between the two, we'd need to add acidified potassium dichromate. And of course, an aldehyde can be oxidized to a carboxylic acid and will change the dichromate from orange to green. A ketone will not be oxidized, and so it will stay orange. The acidified potassium dichromate will stay orange. Again, notice we've got some peaks at 1000 to 500. Just ignore them, that's just the fingerprint region. So, about 5 more minutes left, guys, off we go. And this is the last one. Halfway through. Okay, guys, so that was IR. Thank you very much. I'll see you next time.